An extra example of problem of relative velocity. So I'm going to do question 61 in your book. So I have two ships, ship A and ship B. They're leaving port together for the next 2 hours. So the delta T will be 2 hours. Ship A will travel at 20 miles per hour in the direction 30 west of north. So I have north here. It's out, and this one is going at 30 degrees west of north, so that's 30 degrees right here. That's ship A, and the speed of ship A is 20 miles per hour. And then, while ship B travels 20 degrees east of north, this one is 20 degrees at 25 miles per hour. So this is B, and VB 25 miles per hour. All right, what is the distance between the two ships 2 hours after they depart? What is the distance between the two ships 2 hours after they depart? That's the first question. Well, I guess I could just say A is going to move at 20 miles per hour for 2 hours, so it's going to move. This one is not relative velocity so much, so the next one will be, but I do. So the first one move at 20 miles per hour for 2 hours, so he does 40 miles this way, while ship B will do 50 miles that way. Okay, and so this is 30 here, this is 20, and I would like to know the displacement between these two here. So what is that vector here? So if you call this R1 and this is R2, this thing here would be R2 minus R1. Okay, and I can then just find the magnitude of that. So this is a good vector problem, so let me do this really quickly. And then the next question B is really going to be about relative velocity. But let's see, R2 here, so we say the length of R2 is 50 miles. So let me put X and Y coordinates here. So when you want to do vector, so it's 50 miles because I went for 2 hours at 25 miles per hour. So R2 will be something in the X direction. So the X component of R2, if I look at this sign here, so if I draw this is R2 here, this is 20. The X component is the opposite side to the angle. So it's the R2, the X component will be 50, the hypotenuse times sine of 20 in the I hat direction. And then in the J direction is just plus 50 cosine of 20, J hat direction. While R1 is 40 miles, and now sine of 30 in the I hat direction, because now the angle is sine. Note also that there will be a minus sign here, because this one is in the minus X direction, plus 40 cosine of 30 in the J hat direction. So these are my two vectors. The distance, these are the kind of the two position of each of them. The distance between them will just be this one minus that one, will give me this vector here. This is kind of the displacement as if you were going to this from this final position to this initial position in some sense. So R2 minus R1, and then you just do this for each one. So it becomes 50 sine of 20 minus R1, so plus 40 sine of 30 in the I hat direction. And then in the J, I get 50 cosine of 20 minus 40 cosine of 30 J hat direction. And then finally, the distance between the two is the magnitude of this. So it's this thing square plus this thing square. These are just numbers I can put them, and then the square root of that. This is actually a little complicated way to do this. Question B is asking, what is the speed of ship A with respect to ship B? In fact, this will allow us to find the distance they travel way faster. So let's do this. Question B. So I have two ships traveling. What is the velocity of A with respect to B? Okay. Well, I know that the velocity of A with respect to the water is, so again, I can go back here. So it's essentially the same vector, so it has exactly the same component of this. But now instead of distance here, I'm going to use velocity, so it's not 40 miles, but 20 miles per hour. So velocity of A with respect to water is 20 miles per hour times sine of 30. That's in the minus I hat direction. And then I get a plus 20 miles per hour cosine of 30 in the j hat direction. This is all the units of that is miles per hour. Okay, so that's the velocity of boat A with respect to the water. Velocity of boat B with respect to the water, well, now the velocity is 25 and the angle is 20, but everything else is the same. So 25 sine of 20. It's also in the positive x direction, so I don't need a minus sign. Plus 25 cosine of 20 j hat miles per hour. Now very often the cosine is with the x direction and the sine is with the j direction. Here, because I'm measuring my angle from the y-axis, this is inverted. But if I had measured my angle from the x-axis, it would have been the usual cosine in the x and sine in the y, so this would have been reversed. So just always be careful and look how is your angle measured, and then you can find which one is the sine and the cosine. This step is the crucial part of vectors that we're doing at this point, is the ability to write a vector in terms of its component. But now we have an extra also relative velocity problem. We don't want the velocity of the boat with respect to the water. We would like the velocity of the boat VAB. So I have three objects. I have A, B, and C, and water, sorry. The formula for relative velocities on your formula sheet, you can take any one. Let's say I take VAB. Then this is equal to VA. Then you put the third object, water. And then plus V, water, B. So the idea is that the water kind of cancels here. So this is how these three velocities are related. The velocity of ship A with respect to ship B is equal to the velocity of ship A with respect to water plus the velocity of the water with respect to B. Now, we don't have water with respect to B, but we have B with respect to water. These are all vectors. But just changing the point of view, water versus B, or B versus water, or water versus B, just change the minus sign. So this is really the same as VAW minus VBW. Okay. So if I do these, I get that VAB is going to be, so it's minus 20 sine of 30 minus 25 sine of 20 in the high hat direction, and then in this one plus this minus that, so that's 20 cosine of 30 minus 25 cosine of 20. Sorry, this is in the j hat direction. All right, and that's it. Looks messy, but that's it. That's the velocity of boat A with respect to boat B. And if I wanted to know the distance that A has traveled with respect to B, I would just multiply VAB by 2 hours. So all of these would become, instead of 20, this would be 40, this would be 50, this would be 20, this would be 40. And then the distance, that would be delta R, and the distance would be the magnitude of that vector. The magnitude of this vector. And this would be exactly the answer we had before. In fact, it looks extremely similar. Remember that these were the things here? This is essentially the same thing. So in other words, I can go and find a displacement, or I can just say, well, with respect to B, how fast was A moving? It was moving with this velocity. And it went up that far. All right, this is one extra problem. Hopefully you find this useful. Thank you. This is problem number 61.